Today we're going to take a look at some of the exciting changes with the new generation 𝗣𝗲𝗸𝗀𝗀 preferred large format interchangeable cores, specifically Sargent style and 𝗂𝗏𝗏𝗏𝗏 style, and I know you're going to like what you see. First, our plan is to note the visuals, the similarities and differences between these two cores. We're going to take a look at the improvements. Then we're going to see the components that will be used. We're going to do the math, which is simple. Then we're going to combine these cores and test them to make sure they work beautifully. Now, comparing these two interchangeable cores, you're going to note that when you see them on the face, you're going to see the P, which stands for preferred, and that's on the plug face. They have been re-engineered for quality and assembly. The plug has been changed and redesigned also for assembly improvements. These two cores will use the bottom pins known as J bottom pins from our pin kits. The next thing we need to do is talk about the specific components that we are going to use. Both cores use spring retainers at the very top to hold in the springs and the pins. The Sargent uses the 6800, whereas the 𝗂𝗏𝗏𝗏𝗏 uses the 3425 style. The Sargent style also will be using a timing pin, and the purpose of that is to engage the slot in the sleeve, and it is necessary. The reason is that it creates a positive key pull stop for the control key. Without it, it will be difficult to remove and insert the core into its housings. All the chambers will have a control area, and that will be over all 6 chambers. These are large format interchangeable cores, but they utilize an SFIC pinning system. You should also know that the Peak's patented pin stack already contains the bottom pin from the factory. It's sealed and you don't have to worry about putting that patented bottom pin in. You will, however, place the top pin in that's patented over that. There is no 7B build-up pin on top of that because you don't need it for the interchangeable cores. Our next step is to take a look at the components chart, which is very important when you are working with these cores. This is our components table, and as you can see, this line shows the 𝗂𝗏𝗏𝗏𝗏 style core, and this shows the Sargent style core. The only difference will be the 2 different spring covers that you see in this column, and the fact that the Sargent core uses a timing pin. Now, in order to do the math, we have to do it first on paper. For this particular set of cores, our pin stack total will be 26. We are going to be dealing with uniform pin stacks. In SFIC, we are using the A2 system, which is the most common. That means that our cylinders will be pinned from the back to the front, and the keys will be used engaged tip to bow. So what we need to do now is look at the math that we have already done on paper, and I'll show you how easy it is to do. Here we have our coded pinning chart. This is going to be for our Sargent and 𝗂𝗏𝗏𝗏𝗏 style large format interchangeable core. Now, our pin stacks will total 26. You can see all 6 pin stacks laid out here. The first thing we're going to do is put down our regular biddings in the correct spots. Notice this dark black line. Everything above will be the biddings that we will be using. The top bidding is our control key bidding, and we've written that in red. Underneath that, we have the top master key bidding in green, and our change key bidding here is in blue. Below the heavy line, we have the actual pins that we'll be putting into the cylinder. It's sort of an X-ray view of the cylinder itself. The first thing we're going to do is calculate our bottom pins and master pins, and that's very easy to do. If you see this thick line right here, everything below it in these 2 areas is what we're going to look at for the plug. The control key bidding has nothing to do with the plug right now, so we don't have to worry about it. We're going to take a look at the change key and top master key biddings. We're going to look for the smaller number. In this case, it's a 3. That automatically becomes our bottom pin. The remainder up to our larger number is the difference that will become our master pin. So in the second chamber, if we take a look, we see a 5 and a 9. 5 is our smaller number. So that will go down and become our bottom pin. The difference from 5 to 9 is 4. That will become our master pin. In chamber 3, it's the same thing. We look at 3 and 7. 3 is the smaller number. That automatically becomes our bottom pin. The difference from 3 to 7 is 4. That becomes our master pin. Very simple. We do the same thing for the rest of the chambers. Now, since we already have the biddings, and this is our system, there's a very easy way to come up with the top pins, and that's what we're going to do first. In regular SFIC, we would use the formula 13 minus the control cut equals the top pin, but we have a pin stack of 26, which is 3 more increments higher, so we must change the formula. Now it's 16 minus the control cut will give us our top pin. So that's very simple math. In the first chamber, we have a 7 control cut. Well, 16 minus 7 will give us a top pin of 9. Same thing here in the second chamber. The third chamber, 16 minus 9 gives us 7. We finish up and we now have our top pins. There's one more element we haven't yet done, our control or also known as build-up pins. Well, there's 2 ways you can do it. For those people who love formulas, the formula is right here. Control cut plus 10 in an A2 system will yield minus the plug total will yield the build-up pin. Now, you can do it that way and it will work. But the easier way for so many people is just to say we have one value we need to figure out. If you know the plug total, which is 5 plus 9 minus 26, that's 14, that gives us 12. That would be our build-up pin. Let's do the second chamber. We know we have a 5 and a 4 and a 9. That totals 18. We need to get that subtracted from 26. It yields 8. That becomes our build-up, also known as a control pin. And in the third chamber, it's the same thing. We already know we have a 3, a 4, and a 7. If we add those up, it's 14. 14 from 26 yields 12, and that's our build-up or control pin. We can finish up our chart by adding in those numbers. Now we have all the numbers we need to successfully combine our large format cores. Here we have the 𝗣𝗲𝗸𝗀𝗖 preferred pin kit for A2 system. Let's take a look at how it's put together. Very simply, the bottom pins are all at the bottom of the kit. We have the J pins in this section here, and we have the A bottom pins for some of our cylinders in this section. All of our wafer pins are here, which are the B pins, and they will run from a 2B up to a 19B. We have our retainers at the side, and we have retainers over here, springs, caps. So everything we need is in the kit itself. What's probably best to do is, from the math that we have done, is take out the pins that we will need, put them on a pinning mat or a pinning block, and begin to prepare for combinating. We have our bottom pins laid out, chambers 1 through 6. Going upward each chamber, we have a bottom pin, a master pin, a control pin, and a top pin. Here we have our springs, and over here for our other components, we have our spring cover, and over here is our Sargent style timing pin. So the next thing to do is to take a look at both of these Peaks large format interchangeable cores. Now, before we actually combinate, we need to take a look at both of these large format interchangeable cores. We're going to show the Sargent core and then how the timing pin slides in so easily. Then we're going to take a look at the 𝗣𝗲𝗸𝗀 core that we are going to actually combinate. What we are going to do is fill each chamber individually until it's completely filled and then move on to the next chamber. Remember, we're going back of the core to the front of the core, left to right, or tip to bow, as in any SFIC small format system. Some of you prefer to use your fingers, some use tweezers. That's up to you, or a combination of both. But be careful to watch for the 4B pins. Sometimes they go in a little off center, and that's easily fixed. As far as the patented Peaks chamber, the bottom pin is already in and sealed by the factory. All you have to do is drop in the patented top pin and no pin above that. So right now, let's take a look at those two cores. First, we have the 𝗣𝗲𝗸𝗀𝗖 Sargent large format interchangeable core. If you notice at the very back of the core, you see a small hole. That's for the timing pin. Let's just take that out of our pin block, and all we're going to do is just drop that in. Perfect. You're done, and now you combine that core the same way you would any other of the Peaks interchangeable cores. But for purposes of this demonstration, we're going to use the 𝗟𝗏𝗏𝗀 large format style interchangeable core. Now, if you notice here, I have a stabilizer tool in one of the chambers. All that does is kind of holds together the plug, the shell, and the sleeve so that all the pins can fall down in a uniform way from top to bottom. We're going to start with the number 1 bottom pin. The first chamber is in the back of the core. Then we're going to drop in our master pin for chamber 1. Then our build-up pin, also known as our control pin. And finally, our top pin. I'll take my ejector tool and just make sure everything's fallen down to the bottom, which it has. Now we take our 2 bottom pin for chamber 2. Drop it in, our master pin, our control pin, and our top pin. You would do all the rest of the chambers in the same identical way that we've just done chambers 1 and 2. So let's continue. The next step is to take a quick look at the top of each chamber, and you can see across from chamber 1 to 6. All of the pin stacks are at a uniform pin stack height, which tells us we've accommodated our core correctly. So the next step is to insert the springs. Now that the springs are inserted, we'll take our spring cover, place it on top. We can test with our keys. We'll take our change key first. Beautiful. Our master key. Perfect. And our control key will turn approximately 15 degrees clockwise. Perfect. Now we need to seal the core. Our core is sealed. The last step is to do a final test, inserting it into a K or D. For our final test, we've inserted both of our 𝗟𝗏𝗏𝗀 style interchangeable cores into a key retainer device. The top master key is locked into position. We take our Peaks change key, insert, rotate, and remove the master key for its authorized use. When done, the master key is returned, turn, and the change key is removed, and now we have seen that both cores work exactly as expected.